All of the information and examples that you need to be able to successfully complete the items on the first exam are presented in the course notes as well as the assigned readings from the course text. But I thought I would take just a few minutes here to present some of the learning objectives for part one and elaborate on them a little bit. Number one, so that you can have a better understanding of how the objectives are used on the exam, but also because the elaborations can help provide a little bit more context for what the information and examples actually mean. So I'm going to start with the first objective for the class, and this is explain what it means to earn a Master of Science degree in education, contrasting it with a Master of Arts and a Master of Education degrees. Now, you will notice that this is an italicized objective, so this is not going to be measured on the course exam, so no items are going to address this. But I thought it was an important objective to include at the very beginning of this course because a Master of Science degree does focus a lot on research, and this is a very foundational course, and it's the reason why you are taking this course as part of the degree. You're earning a graduate degree in a science-related component of the field of education. Now, a Master of Arts in Education is a degree that focuses on the theoretical and philosophical aspects of education. A Master of Education degree focuses on the practical application of teaching methods and strategies. And that degree emphasizes teaching and learning theory, curriculum development, and assessment, which sounds a lot like it would match a curriculum and instruction degree. However, a Master of Science in Education degree focuses on the practical applications of scientific principles to education. So it emphasizes research and statistics as well as the use of technology in your practice. Now, the reason why Radford University offers a Master of Science graduate program in education is because you do have opportunities in your graduate program to actually get involved in conducting research on your own, and you can under the supervision of faculty, and you can apply that to earning graduate credit, but also it's another opportunity to more closely study what it is you're actually doing in your practice. And so we do offer that avenue. You don't have to take it, and most students don't, but it's definitely part of this particular degree program. Now, the next objective I wanted to talk about has to do with describing how science represents a way of knowing and differentiating between science and other ways of knowing. And this is not italicized, so there are going to be some questions about this on the exam. And this is a really important objective because it's something that a lot of people don't quite understand. Unfortunately, the way science is treated as a subject in school, it usually focuses on the content of a particular scientific discipline. And whenever I hear students talk about the fact that they don't really like science, usually what that means is that they don't like a particular content area of science that they were sort of compelled to or forced to have to learn. And it was probably something that was a class that included a lot of new language, esoteric language that they needed to learn. And it may not have been applied to their life. And so I understand why people could say that they don't really like science. But if you understand that science is a way of knowing things, then it makes a big difference in how you look at science and how you value it. Now, of course, there are other ways of knowing things. One common way is just sensing something. You can know things by having stimuli affect your senses, and your brain makes sense of that. You can know things by sharing information with others. That storytelling, gossiping, Certainly, social media in general is a really important way of communicating information and knowledge and knowing things, is watching other people talk about them, whether they're experts or not. And that's why social media it's really, it's potentially an issue with people telling stories on social media without, and making it sound believable and compelling. And yet there may not be any really compelling reason, once you look at it more closely, a compelling reason to accept that what is being told to you, it has some measure of truth to it. Other ways of knowing include just logical reasoning. You can definitely think your way into knowing new things, and that happens to people all the time when they use their imagination to try to solve a problem in their head about something. They're creating new knowledge for themselves. And finally, science. Science is a way of knowing things. A common way of knowing, or a common aspect of science as a way of knowing, is, we call it the scientific method. And it's a way of applying certain rules and principles and procedures to making observations and making sense of them. And that really is the heart of science. And that's one thing that you're going to learn a lot more about in part 1 of this class. Objective 1.5.1, it's related to 1.5.2, and this has to do with you identifying and describing the common steps in the scientific method, which asks you to compare the scientific method model that I present in the notes with the one that's in the book. I put the page number on here in the course text that includes the scientific method as communicated in the book, but I have to tell you that's a very inadequate model of the scientific method. And the one that I provide is much more robust and much more realistic. And the one thing that you'll notice about the model that I present in the notes is that it's, first of all, it's not a linear or a step, it's a circle. Because once you get involved in an investigation in search of trying to make sense of something, you investigate it with the scientific method, and you might come to some conclusions after a particular investigation, but more often than not, more questions are raised, and it's cyclical, and you go through the scientific method again, perhaps under different circumstances. And so study that carefully in the notes. And that's the one that I'm really focusing on for the exam. Also, so important is that the model that I present really shows you clearly the role that good observations play in the scientific method. And it's woven throughout the entire method. I'll tell you what, my wife, is a primary grade teacher, and when she teaches science, anything related to science, she focuses on observation skills, because like me, she recognizes the importance of making good observations in science, so she de-emphasizes all the content and of science and really emphasizes students learning how to describe things in observable ways and not inferential ways and that kind of thing. So that's a very important learning outcome. Objective 1.7 addresses your ability to identify and describe the attributes of a good theory. Now, I begin part 1 with a lot of sort of talk about theory because theory is both a driver of inquiry as well as the results of a lot of inquiry. And I'll tell you right now, I'm going to ask you in this class to apply the scientific method to the study of a theory that supports your practice. And you don't need to worry about that now. That's something that's going to be addressed in the final project of the class. But in terms of what makes for a good theory, I wanted to talk about a theory that a lot of you are likely are familiar with, and that's the theory of where humans come from. How are we here? And one theory that is communicated kind of as we're all growing up in this culture is the theory of creationism. Maybe not as a science, but definitely as a theory to explain how we got here. Now, a good theory includes a logical consistency. That is, the theory itself seems logical. It explains observations. It explains what we can see. It's falsifiable in that you can prove it wrong, and it's also a simple theory. That is, it explains observations in the most simple way possible. And I will say the reason why I have the creationism here is as a theory is that it doesn't break the parsimony rule. It's a fairly simple story. A fairly simple model, but it's not a theory that can be falsifiable, because if somebody believes that a higher power or a supreme being just made everything, maybe in an instant, maybe in a day, or whatever, you could say, well, I have some evidence that suggests that our planet is actually billions of years old. You could say that, and somebody who believes that everything was designed by a higher power could say, well, but that's the way it was designed. And I've seen that argument a lot. So you can't falsify creationism, which doesn't make it a scientific theory. It's a theory, all right, but it's not scientific. So that I wanted to talk about that, and I also wanted to bring another scientific theory in, or a model, I should say, and we talk about in the notes the difference between a model and a theory. But for many years in the history of man, there was a storytelling and a belief and a knowledge that we did live within a solar system. It may not have been called a solar system, but we lived on our planet, that it was a planet, and that it was at the center of this model, and that the other planets that we could observe, they all went in circles around our planet. This model, this theory of the solar system, had some logical consistency to it, because it definitely made sense to think that if you could observe the movement, not very closely, but if you could observe the movement of planets, they did appear to our eyes of moving across the sky. They explain, for the most part, that this model did explain why these heavenly bodies seemed to move across the sky without thinking that the Earth was rotating, but it did explain it. Definitely a falsifiable theory, because you can make further observations and then you have to change the model a little bit. And this is actually a fairly simple, parsimonious model. Now, before there was a wide scientific acceptance, that the sun was actually at the center of the model of our solar system model, scientists did alter the Earth-centric model, because they observed that the planets sometimes at the same time in the night sky, they change their position, and sometimes they seem to move forward at the same time, and sometimes they seem to move backwards. And so they altered the model a little bit to suggest that those heavenly bodies actually moved in their own circles around a bigger circle around the Earth. And that model, again, it's an Earth-centered model, and it did a better job of explaining the motion, the more carefully observed motions of the planets, and it was accepted for a long time until until it kept having to be refined, and then a sun-centric or heliocentric model was proven through a lot of observations and predictions that it was a much more accurate model than something like this. This definitely breaks the rule of a good theory of being parsimonious, because it's very complicated. Objective 1.8 is that you should be able to distinguish between positivist and interpretivist philosophies. And again, I'm bringing this up because I try to tie together philosophies and theories and models and what the relationship are. And in research, we tend to sort of categorize research into two sort of distinct kind of philosophical approaches. One approach, the positivist approach, considers that there are these objective truths out there, and they're measurable and they're identifiable, and through good science and the scientific method, you could actually prove those truths. Interpretivist models are really grounded in the idea that truth is somewhat elusive, or that it's relative. That's a better way to put it. That something that might be true in one situation might not be true in another, and that through our own observations and making sense of our observations, we can get closer to knowing the truth. But there's less of a of starting with an idea of the truth. It's more about discovering it through observations. Now, a good way of kind of better understanding the difference between these two philosophies when it comes to actual research methods is to actually look at Objective 1.13. So I'm going to skip over to it. And this is asking you to differentiate between definitions and examples of inductive versus deductive research models. And I include in the course notes this graphic that I found that I really like. And if you look at the deductive model on the left, the Aristotelian model, it's a model in which scientists would begin with a theory, and based on that theory, they make a hypothesis about something that they have questions about. So they have a question about something. They already have a theory that they're operating under. They conduct experiments or do whatever, make observations, and they confirm whether or not their hypothesis is supported through their observations. That's a deductive model. An inductive model, the Sherlock Holmes model, is where you actually start with observations. So you got to look at you go from the bottom up on this model. You start with observations and you look for patterns in those observations. And once you find patterns, the next question is, I wonder why those patterns exist. And so then you formulate hypotheses about that. And based on your hypotheses, then you might generate a theory rather than test the theory. And you can certainly see how there's there's a place for both of those approaches. It's not one or the other when you're trying to sort of investigate what might be truthful about something. If truth is even a thing is even possible. Now here's an example, okay, of the difference. So suppose you were investigating the impact of mindfulness. You were a researcher looking at mindfulness in education. So here's a deductive way of thinking about mindfulness. So we already know, based on other research and maybe through storytelling, through what somebody told me on TikTok, Mindfulness meditation reduces stress, and reduced levels of stress lead to greater success in the classroom. Therefore, mindfulness meditation leads to greater success in the classroom. So you can make that hypothesis, and then you can go and test it. You can do an experiment. That's a deductive way of looking at studying mindfulness in the classroom. An inductive approach looks like this. Some of the students in the classroom being observed demonstrate much more success than others. Most of the students demonstrating success regularly engage in mindfulness meditation. Therefore, mindfulness meditation leads to greater success in the classroom. You end up with the same hypothesis, but you're coming about it from your own observations, which is why usually inductive approaches to problem solving or to science and the scientific way of thinking, it usually involves some point of really making a lot of observations with an open mind. In this case, going in and studying students who just studying what might make somebody successful and taking a closer look at it and observing certain things and looking for patterns. In this case, the pattern is that all the kids in this class seemed to practice something to help them deal with stress. But again, there are confounding variables, aren't there? Because perhaps somebody who either who does mindfulness is growing up in an environment in which they learn how to manage stress through lots of different ways, and they just have a healthier mindset. And in that way, they may be successful. And it might not have anything to do with mindfulness, but it might have to do with being raised in a family that values addressing stress in a positive way. So, that's why you have to study it further. The next objective that I wanted to talk a little bit more about has to do with variables. And one of the things that is going to be applied throughout the next couple of parts beyond part one are the different types of variables that are part of any research investigation. And those include dependent, independent, and possible modifier or grouping variables. And in this case, I want you to be given a hypothesis. I want you to be able to identify what those are. Now, just a quick reminder that an independent variable is a variable that's manipulated or changed on purpose. That's because you believe as a researcher it's going to have an impact on something called the dependent variable. So in our mindfulness example, the independent, if you were going to study this, you'd obviously want to have some kids undergo mindfulness training and practice it, and some kids not, and then you'll measure their success in school. So in that case, the mindfulness practice, training and practice would be the independent variable, and their success in school would be the dependent variable. Now, a modifier might be a grade level, or it might be a sex, male versus female, or again, age, grade level, or something like that. So, and that might be of interest to the researchers for some reason. And usually there's a compelling reason for believing that there's another variable that might influence the relationship between the independent and dependent variables. So I was thinking about, in talking about the different types of variables, I was putting notes together, and it was near Father's Day. So I was thinking about fathers, and I was thinking about a hypothesis that may or may not be true. But the hypothesis that I was thinking about is that the more time a father spends with his daughter, the more successful she will be in life. And there's a lot of research out there about this, or a lot of ideas about this. But I wanted to just, I have two daughters. I have a son as well, but I was thinking about the relationship between fathers and daughters, and this is a hypothesis. And if you look at this hypothesis, the amount of time a father spends would be, in this case, be the independent variable. So the success in life would be the dependent variable. And then the moderator variable in this case would be the daughter. if I said the more time a father spends with his children, the more successful they will be in life. I would want to look at the difference between daughters, sons, and perhaps anybody in the middle there, because just because there's a lot of work done on the differences in those relationships, and there's a reasonable assumption that those do have an impact on life in some way. Now, I'm going to talk a little bit more about that in just a second, because I wanted to go back now to objective 1.10. One of the things that you're asked to do is to identify research problems that are good, and that is they meet the conditions of feasibility, measurability, clarity, significance, and ethicality. So again, a good research problem versus a bad one includes these characteristics. A good research problem is feasible, clear, measurable, significant, and ethical. Ethical. That's the one I wanted to talk about, because if you were to experiment to test your hypothesis, you could test this hypothesis that the amount of time a father spends with his daughter will influence their success in life. You could test this hypothesis experimentally if you wanted. And your experiment could be you manipulate the amount of time a father spends with his daughter. You could have an extreme and say almost no time versus all the time. I don't know. But that wouldn't be a very ethical approach, because you're taking a parent away from a child on purpose. And there's a reasonable assumption that isn't going to turn out so well. Especially since you're operating under the assumption that there will be some relationship there. So that would be unethical. There are other ways to study it that could be very ethical. And so when you formulate a problem, you would have to qualify it somewhat. Now on the exam, I'm going to be giving you pairs of problems, and you just have to pick the one that meets those criteria that makes for good problems. So here we have two related problems. Number 1A, are heuristic approaches to teaching problem solving more effective than theory-based methods? So, or is problem-based learning instruction as effective as lecture-based methods for teaching problem solving skills? The big problem with 1A is that it's not very clear. You might not know what heuristic is. It has to do with sort of stumbling across it on your own. It's an open-ended approach to lots of things, but it's an open-ended approach to teaching. So it's not very clear, neither the term nor what that would represent necessarily. So this one is a little bit vague. I'll give you a more clear one here. So which is more worthwhile, or a better research problem? Are school counseling programs worth it, or what are parent attitudes towards school counseling programs? Now, I think obviously the second one is a better research problem, because it's measurable and it's clear. It's clear. I don't know in 2A what worth it means. That can mean a lot of different things. So in this case, the better research problem would be one in which, okay, parent attitudes, I can definitely measure that. And it's addressing a specific thing about school counseling programs. So I just wanted to talk a little bit about those objectives and just say a little bit more about it. As I mentioned, there are other objectives I didn't talk about that are going to be measured on the exam. And if you want to know how they're going to be measured, again, just take the practice exam and you'll have a better idea of that. So just wanted to give you a little more information about some of the material for part 1.